Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is minimum number of flips to make binary grid palindromic 1. In this question, we are given a m×n binary matrix called grid. A row or column is considered palindromic if the values read the same forward and backward. We can flip any number of cells present inside the input grid of size m×n from 0 to 1 or from 1 to 0. Each operation is considered one flip. This is one flip. And this is also one flip. Our task is to return the minimum number of cells that we need to flip to make all of the rows palindromic or all of the columns palindromic. Let's take the first example and see how we can solve this question. I've taken the same example as example 1. Now we have 3 rows and 3 columns. So rows is equal to 3 and columns is also equal to 3. Now we have to check how many minimum number of flips are needed to make all rows palindromic or all columns palindromic. We have 3 rows. So for rows, we can directly iterate through the grid array. So let me tell you how we can check if an array is palindromic or not. So let me take a sample array 2, 3, 1, 3. So this is a palindromic array. I'm going to take 2 pointers, start and end. So start is going to be at the 0th index. Let's take the index position 0, 1, 2, 3 and 4. End is going to be at, this is AR.length is equal to 5 minus start minus 1. Length is equal to 5, start is equal to 0, minus 1 is equal to 4. So we see end is at 4 and start is at 0. Now we have to check if start and end are not equal. If start is not equal to end, then we can increment flip. So I create a variable flip. So initially it is 0. 2 and 2 are same. So now start will move forward. So start is now here and end will move to the left. We are doing start plus 1. Now start is 1 and end minus 1. So end is at 3. So we can see end is at 3, length is 5, start is 1, minus 1 is equal to 5 minus 2 is equal to 3, so 3, so end is at 3. So that is why we took this formula, ARR.length minus start minus 1. Now again we check if start and end are same. Yes, they are same. So start is now here and end will move to the left, end is here. Now as soon as start and end are equal, we can end the iteration. Till now flips is equal to 0. It means it needed 0 flips to make this array palindromic because it is already palindromic. Let me take a different array now. Now if start is here and end is here. Start and end are same. So start will move forward and end will move backward. Start and end are not same. So flip plus plus. So flips incremented by 1. Now move start forward and end backward. Now as soon as these both meet, we end the iteration and flips count is equal to 1. It means it needed 1 flip. So we can either make this to 4 or this to 3 to make the entire thing palindromic. So now we do the same for all the rows. So this entire code will be inside a helper function and we pass it for each row and each column. Now we pass this into the array and we see that we need 1 flip. We pass this and we see that it needed 0 flips. We pass this and it needed 1 flip. So for rows flip is equal to 1 plus 0 plus 1, total is equal to 2. And now we have to do the same for columns. So for columns we can't directly loop. We have to take nested for loops and pass in 1 column at a time like this. I'll show you during code how we can pass columns. And now we pass the columns. So for that I create another variable column flips and we pass the first column, again it needs 1. We pass the second column, it needs 0. Pass the third column, it needs 1. So total again is 1 plus 0 plus 1 is equal to 2. And if you see the question, we need the minimum number of flips to make all rows palindromic or all columns palindromic. And we take the minimum of them. So min of 2, 2 is equal to 2. So 2 will be the output. Now let's implement the same steps in a Java program. Coming to the function given to us, this is the function name and this is the input grid given to us. And the return type is an integer representing how many number of cells we have to flip to make either all rows or all columns palindromic. Let's calculate the number of rows and columns present inside this grid. And columns is going to be grid of 0. We're taking the first row and calculating the length of the first row. We'll get the columns. Now we have to check if either all rows are palindromic or all columns are palindromic. So for that, let us create a function which will take in a 1D array representing either a row or a column and calculate the minimum number of flips to make that particular row palindromic. And using this helper function, we can apply it to all rows first and then all columns. And when we compare the two, we can take the minimum number of flips to make either all rows or all columns palindromic. So this is going to be a private function which is going to represent an integer representing the minimum number of flips. I'm going to name it find min flips, and it is going to take a single array as input. So this is going to return an integer, so let's declare the return variable. I'm going to name it flips. This is initially 0. Now we have an array. Now we have to check if this array is palindromic or not. So I take two pointers. First pointer is at the beginning. I'm going to name start is equal to 0 and take another pointer at the end, and end is going to be arr.length minus start. Start is initially 0 minus 1. But now start will move from left to right and end will move from right to left. Now until start and end meet, we do the same. So until start is less than end. Once they both meet, we can end the iteration. So whenever start and end are not equal, then we increment the flip. ARR of start is not equal to ARR of end. Then we increment the variable flip. It means we need one flip to make both start and end equal. And now, like I said, start will keep moving forward and end will keep moving from right to left. And this will happen until start and end are equal. Then this function is going to return the minimum number of flips needed to make a single array which can either be row or column palindromic. Now let's apply this function for all the rows. So in this array we know there are 3 rows. So we have to apply this function 3 times. So int I equal to 0, I is less than rows, I plus plus. Now we are calling this function rows present inside this grid. So grid of I. So it is going to take this array first, then it is going to take this array, and then it is going to take this array next. Now we have to store this output. This will return the number of flips for one row, and we are applying it to 3 rows. So we have to count the total number of flips for rows. So I'm going to create a variable row flips, which is initially 0, and we're going to use this to find out how many row flips are needed for all the rows. Now let's do the same for columns. I'm going to take a variable column flips, which is initially 0. Now we can't directly do this for columns because initially rows are directly available inside arrays. Now we have to take these values 1 0 0 0 0 0 0 0 1. So let's see how we can do that. I'm going to use a nested for loop. So first we need to iterate through the columns, right? So let's see how many columns are there. So initially it is going to be 0 until the total number of columns. Now we can take one column at a time. So let's declare a variable column, and this will be of the size how many rows are there. Now let's iterate through the rows. So now we fill this column of j is going to be grid of ji, right? Because we are first taking all the column elements in the first column and then we go to this column. So now we have one column ready. As soon as you have one column ready inside this for loop, after this for loop ends, we have one column ready. Now we have to find number of column flips for that column. So calculate the same way how you calculated row flips. You pass in this helper function for that particular column. Now we have row flips. And once this for loop ends, you calculate the column flips for all the columns. And now we have to calculate the minimum number of cells that needed to be flipped to make either all rows or all columns palindromic. We have the two values, row flips and column flips. We have to return the minimum of them. So return min of row flips, that is this value, comma, column flips, that is this value, and minimum will be returned. Now let's try to run the code. The test cases are being accepted. Let's submit the code. Our solution is accepted. So the time complexity of this approach is big of m into n. M represents the number of rows and n represents the number of columns. And the space complexity is big of n. M represents the larger of row or column, whichever count is more. That's it guys. Thank you for watching and I'll see you in the next video.